Okay, in this video I'm going to talk about the cardiac cycle and the three phases and the highlights of each of these phases. So the cardiac cycle is basically all of the events that are occurring within the heart during one heartbeat, and this includes changes in pressure and volume of blood. I recommend, if you're watching this video, to kind of follow along with your notes. Unfortunately, I'm not going off of my notes. I'm going to use this animation that I showed in class, but hopefully I get pretty close to what my notes say. So the first phase of the cardiac cycle is called the ventricular filling phase, and at this point the pressure in the heart is quite low. The AV valves are going to be open, and when they're open, blood is just flowing passively into the ventricles, and this is due to gravity. And the majority of this atrial blood is just going to flow passively into the ventricles. And when about 80% of the blood is in the ventricles, these AV valves are going to start to close. They're not going to completely close yet, but they're going to start to close because the pressure in the ventricles is increasing. Now, the atria are going to depolarize. This is after that 80% is already in the ventricles. So they start to depolarize, and that's what we can see down here on the EKG. So we can see right here, this is where we're at. We're starting to depolarize the atria, and following that wave of depolarization, we're going to have contraction. And the atria are going to contract, and they're going to push the rest of that blood into the ventricles, that 20% of blood. And when this happens, you have a small increase in atrial pressure, which is seen right here. So we have this little increase. This is right when the atria are contracting. Okay, so we have an increase in pressure in the atria at this point, and they push the rest of that blood into the ventricles. Now, all of the blood is in the ventricles at this point. The atria are going to be filling right back up, but the ventricles have their maximum volume of blood, and this is known as preload, also known as end diastolic volume. Okay, so the volume at the end of diastole. The ventricles are approaching the end of their rest period, so they're about to contract. So that's kind of where we're at now. So we've depolarized the atria, they have contracted, they've pushed the rest of this blood into the ventricles, and we can just follow it along down here. So this is, again, depolarization of the atria, the P wave, and as we kind of move along, we can see that the ventricles are filling up, and at this point, the ventricles are starting to depolarize. And when they start to depolarize, like I've said in class, following that wave of depolarization, you're going to start to have contraction. So at this point, we still have our end diastolic volume, we have the maximum volume of blood in the ventricles, and they are about to start contracting because we have our wave of depolarization, which is the QRS complex on the EKG. So right at this point, we have closure of the valves. So the pressure in the ventricles causes these the AV valves to close. And that's what gives you the first heart sound, the S1 sound. That's the lub and the lubbed up. However, there's another kind of a special little split-second event occurring here, and that's the ventricles are contracting, the AV valves are closed, but also the semilunar valves are closed. So therefore, the ventricles are contracting, but they're not pushing blood anywhere. This is known as isovolumetric contraction. So the chambers are completely closed, meaning none of the valves are open, but it is contracting. And this is just a very small split-second event. All right. But as the ventricles contract and pressure increases in these chambers, it's going to force the semilunar valves open, because the pressure is greater in the ventricles, so it's going to open the semilunar valves, which we will see right there. So at this point, the semilunar valves are open. This one is the pulmonic valve, but the same thing is happening in the aortic valve, and blood is being ejected into the vessels, so into the pulmonary trunk and into the aorta. And this is known as the ventricular ejection phase. And again, you can follow all of this on the graph, all of these pressure and volume changes. I really care more about, as long as you know what's going on and why things are happening. This graph just kind of demonstrates it in a different type of way. So that's kind of the phase two, the ejection phase. Now, Phase 3, this is known as the isovolumetric relaxation phase, which I'll talk about what that means in a second. But the ventricles are contracting, the semilunar valves are open, as we can see here. So we have complete contraction. This is following the QRS complex, following the depolarization, and then we are going to enter repolarization of the ventricles, and that's the T wave. Now, the final phase, isovolumetric relaxation phase, this is after the T wave, and this is when the ventricles start to relax. So if we kind of followed along here, the ventricles are starting to relax right about here. Now, there is still some blood within the ventricles, and this is known as the end systolic volume. Okay? The thing is, when the ventricles are starting to relax, the ventricular pressure is going to drop, and that's because the blood isn't being compressed by the ventricles. And with this, the pressure in the pulmonary trunk, which we see here, as well as the aorta, it's actually going to be greater than the pressure in the ventricles. And what happens is you will have closure of the semilunar valves. So here it's open, here it's closed, and that's where you get the second heart sound. That's the S2 sound, the dub or the dup. I mentioned in class about the dicrotic notch. This is when blood kind of hits the aortic valve and kind of bounces back. That's more of a fun fact. But it's that pressure being greater in the pulmonary trunk and the aorta that's causing the semilunar valves to close. Now at this point, you can see here that still both the valves are closed. So the ventricles are closed chambers, and this is known as isovolumetric relaxation because the ventricles are relaxed, they're in diastole, but the volume is the same because no blood is coming in and no blood is leaving. So again, if we and those are the three main phases. So if we kind of go through this again in the second heartbeat. So the P wave, this is atrial depolarization. Blood is passively flowing into the ventricles. The atria are going to contract following this wave of depolarization. They're going to push the rest of that 20% of blood into the ventricles. At this point, the ventricles have the greatest amount of blood they're going to have, the greatest volume. This is known as end diastolic volume or preload. And the ventricles are stretching here, as you can see. And then the ventricles will start to depolarize. And following that wave of depolarization, we're going to have contraction of the ventricles. As they start to contract, there it happened right there, you have closure of the AV valves. Also at this point, AV valves are closed, the semilunar valves are closed, so we call this isovolumetric contraction because the ventricles are starting to contract, but the volume of blood within those ventricles is the same. Iso means the same. However, as pressure increases in the ventricles and it becomes greater than what is present in the pulmonary trunk and the aorta, these valves open right there. So the pulmonic valve in this case opens, and the ventricles continue their contraction. They push blood, they eject blood into these vessels. Once we hit the T wave, we start to repolarize the ventricles. So at this point, the ventricles are starting to repolarize, and they're starting to relax, and then right here we have closure of all the valves again, and this is known as isovolumetric relaxation. So the ventricles are in diastole, and all of the valves are closed, and then the cycle begins again.